Hi, welcome to this first session of operation modeling and simulation. Today we will learn our first steps with witness simulation software. The purpose of this session really is to tell you more or less how witness works in a very simple manner, so then you will see in future lab sessions more details on more advanced models. So today try to use the best of your time in order to make sure that you understand every element and how a model can be created. Today, just to be simple, we're going to start with a very simple model. Basically, that is about considering a part that is arriving to a buffer, then a machine is going to take that particular part from that buffer. And here in the PDF that you already got available on Vital, you will see a lot of the details about each component, like the time of arrival, the inter-arrival, at what time a part arrives, the details on buffers, and the details on the machine. Now, what basically happens here is that a discrete event simulation is basically triggered by the parts. So every part basically are the one that activate every event. Therefore, is how you can see it. I mean, is how you can see how the clock moves. So having a quick look to the PDF, you will see there is all the detail that you need to know in order to get your first approach to witness. Of course, in the second lecture, sorry, you will see you should have seen more details on how to quickly create a witness model. Still, this video will help you with the first lab session. So the first thing that we will do is that we're going to drag and drop the different elements as we have defined at the very beginning. Then we're going to rename every part, every component, which means that we're going to put A1, B1, and M1. And after that, we need to put the logic so that we can say how every part goes to every buffer, and then from every buffer, how every machine collects part from there. And in the end, we send the part out of the system so that the simulation is finished. Now, what happened here is that witness basically works under two main functions, which is the push and pull. That's why I connect with operations management. Therefore, what we need to do is to activate the different elements on the menu so that we can set the output rule or the input rule. So we can see here, so part A, right, is going to push to B1, then M1 is going to pull from B1, and then M1 is going to push to ship once it has finalized. Then, of course, if you want to see or you want to contrast if what you have defined is the reality, or if the part are really following that particular logic, you can activate the element flow view. So once you do it, you can see what is the flow that every part is going to follow. This functionality is very useful since you can really test or at least validate that what you said that the model should be doing in terms of the flow of part is the right or not. Then, of course, we can see that once we double click every element, we can just see all the details. Right? In the main principle here is that witness works under this approach. We have an input section, we have the process section, and then we have the output section, which is what makes the model works. Then another aspect to consider before we create our first model is that the model does not consider the units, which means that whenever we put a number, let's say 4 minutes, but we put a 4, witness doesn't really know which units they are. We need to tell to witness which units are we looking at using. Therefore, if we do menu, model, and clock, you will find this this particular window, and then you can select which units are we going to use. In the bottom of the layout, you will see that there is a lot of buttons. Those buttons are basically regarding to how we can run the model. So we can restart the simulation, start from zero, stop, do like a batch, step by step, run the simulation, and then a batch. A batch is very useful once the model is ready and then you don't want to wait a long time for the simulation. Therefore, you just need to click on batch and the simulation will run instantly almost. Also here, if you want to put a specific time, let's say 1000 minutes, you need to put here that number, right? And you activate the bell. So with the bell, you're saying that the maximum amount of time that Witness is going to consider to run your model is going to be in this box. Finally, is the speed. So here we have the speed of the model. You need to activate this little small person. So once it's activated, we can play with the velocity of the animation, but also we can play with how quick every graph is updated as well. So eventually, when the model is very simple, it's difficult to realize this functionality, but once the model is complex, it can be very useful. So in the end, once we run the model, we can click on this element. So we activate all these boxes. We right click over simulation, and then we can see all the statistics. So basically, the statistics in Witness is about telling us exactly how the model has behaved from different point of view. So let's say parts, buffers, or let's say machines. So all of them have different type of statistics. In our particular case, we will see that 166 part enter and 166 part leave the system, which means that all the part that got into the system got out at the same time. Then we can see that there is no working process, which means that there is no part in between. Nevertheless, we can see some average time working process, which means that part didn't go through straight. There were sometimes in between a part arrived till they left. So, and finally here we can see that every machine has their state, which means that here was 83.4% of the time idle, then 16.60 busy, and so on. And then it's expected that you will do this exercise. So, but let's do let's do our first model. So we're going to start basically from our first picture, which is this. So we need to create a part A1, B1, and M1. For doing so, we need to drag and drop the different elements. Conveniently, part, buffer, and machine were named in that way, so then we can do it. So if we do this, so the first thing I'm going to do, we're going to drag and drop part A, then drag and drop the buffer, and then drag and drop the machine. As you can see here, at least in my case, this looks very small. So I just need to click on the layout and then just zoom in. So I think that that is a nice view of it. So very quickly. So in order to rename this, we have right click over that element. This is going to be A1 intro. Right click. This is going to be B1 intro. This is going to be M1 intro. Then the next thing that happened here is that, as we saw in the model, is that A1 is going to be pushed to B1 and M1 is going to pull for part from B1. So therefore, here, whenever I click over an element, you can see that this section here is activated. So I'm going to generate the visual output rule. So just click there, click yes. So here it's telling me where, if this is going to be a push rule, where is it going to be? So just click over B1 and then click OK. Then M1 is going to pull part from B1, so I need to set the input rule. So in this case, I say visual input rule, pull from where? From B1, and then click on OK. Finally, the output rule is going to send part to ship. I don't need to write it. Here is just the direct button to do it. So click to ship and OK. The other thing that we mentioned is that we can check if the flow is the correct one. So I just need to click here in view, element flow, and okay. So clearly the model is doing what I was telling them to do. I want to make this bigger a little bit so then we can see it with more the graph. So I'm going to mark this like this. Now you may have noticed that, for instance, if you want to say separate name with element, like this buffer, for instance, this buffer is moving, this name is moving everywhere and eventually can get lost. If you want to be sure that every element is connected to the graphical element, basically we need to make sure that the lock is closed. Right? In that case, we can see that in hem. In that case, we can see that that every part moves together. So lock M is make that happen. Now, based on our rules, we said that we were here. So we said that every part, let's see, this is detail. So every part arrives every 6 minutes. So I just need to double click over this part. So it says every part arrives every 6 minutes, which means is the inter-arrival time, 6 minutes. And the first arrival is at the 6 minutes as well. So we have number 6 here as the first arrival. There is no limit in terms of the maximum number of arrivals, and there's also the lot size is 1. The lot size is very useful once you want to model a huge amount of parts in one go, so you can set that particular lot size as you want. Then with the buffer, we don't need to do anything, and with the machine 1, we know that the cycle time is 4 here, and that's basically all. Yes, let me show you that once we did the previous connection graphically, basically witness this expression internally. You can write this expression internally by yourself later when you become more familiarized with the tool. So by doing so, I'm going to save the model. This is very important. So I'm going to save this last session. So this is last session 1. So this is model 1.1. Model 1. It is very important to say the model every time, because whenever the license is not active, there is a potential risk that the model will crash. So the thing that we said is that we want to run the model by 1,000 minutes. So I'm going to quickly do this to the slides. So here with 1,000 minutes, so here I can activate the clock there. And also I'm going to activate the animation. So the animation is activated. Now, important is to remember that in the model clock menu, I can set the units of this simulation model, which in this case is in minutes. It can be in other units. So of course, if you put the model in a specific unit, you need to make sure that if you want to talk about a different unit, you make the right conversion. So if we talk about an hour, it should be 60 minutes. And vice versa, of course. So based on this is basically this is our model. So we need to run the statistics. So I just put the clock, so you will see that the model will run. So it's running very quickly. So I'm going to make this model run faster now, even faster. So you can see that the model is running quickly. So here is actually the time. So the model is expected to stop at 1,000 minutes. So once I stop the model, which is good, basically I need to go to element 3 option. I click in every element, I right click over this, I go to statistics, and then I can see this. So basically here what happens is that I can see the number of parts getting into an auto. Of course I can see some chart as well. So the number of parts that got in, the number of parts that out. I can see more graphs, for instance, in the buffer. There's some chart in the buffer as well. But also more importantly, I can see uh, the state of the machine, how much time was idle or busy. So here I can see some statistics. This is very interesting because here you can see that the most of the time was busy, not that the idle, and these were all the number of operations. We're going to see later in other lab sessions that the number of operations is a good variable to be considered for preparing your model. But also we can see, this graphic which is very interesting, which shows us exactly the portion of time that was idle, which is yellow, and the portion of time that was green. Now, those colors, very interestingly, you can see that as well on Witness. So let me show you how to do it. Basically, you see that this element has a small box in yellow, so that is the box that changed colors. But what every color means, that also can be seen here. If you go to Model, View, Keys, and Machine. Then we draw this someplace, and there we go. So this every color, so we know what it means. So yellow means wait for part. Of course, the model already finished, so it's waiting for parts. But whenever it has a part inside, get busy, or if it's possible that a part cannot be delivered, get blocked, and so on. So the next step for you will be to, as a task, will be to create this example. As you know, this is your task. So you have part A1, B1, and M1. Then you need to use this percent for function at M1 output, and then send part to here and to B2 and B3, create M1 and M3. Well, you will see what is the meaning of this. And you need to see, of course, the behavior of this. So it's fully advised to answer the following questions. We hope that you have enjoyed this first lab session, and next video is going to be available before just before the next lecture. Thank you.